For question number 7, they say that 3 points A, B, and C lie on a line of greatest slope of a plane inclined at an angle of 30 degrees to the horizontal, with AB is equals to 1 meter and BC is equals to 1 meter as shown in the diagram. A particle of mass 0.2 kg is released from rest at A and slides down the plane. The part of the plane from A to B is smooth. The part of the plane from B to C is rough, with the coefficient of friction mu between the plane and the particle. So for part A, given that mu is equals to under root 3 over 2, find the speed of the particle at C. So for this question, the final goal is to find the speed of the particle at C, and the condition that they've given us is that the part of the plane from A to B is smooth. What that means is that there's no friction from A to B, but they're saying that the plane is rough from B to C. That means there's friction in B to C, and this particle is moving downwards. So first we'll resolve the weight of the particle. We'll have two components. Since the plane is inclined at an angle of 30 degrees, this angle inside will also be 30 degrees. And there will be a downward component of 2, since that is the weight. This will come 2 cos 30. And the component that pulls it downwards will be 2 sin 30. Having no friction means that the acceleration of the particle at AB will be higher and different than BC, since no friction means no resistive force. So this question will be done in two parts, since it is part of one journey from the particle that starts from A and then ends at C. The first part, which is the journey from A to B, what we know is that the distance is 1 meters. So distance is 1. And we know it's released from rest, so the initial speed will be 0. And we are unaware of the final velocity, which will be the velocity at B. And we don't know the acceleration as well. So in order to find the velocity of the particle at B, we need to first find the acceleration. We can do that using the forces formula, which is forward force minus resistive force is equal to the mass multiplied by the acceleration. So the forward force will be this 2 sin 30, and there will be no resistive force since there is no friction in AB, and the mass is 0.2 A. The acceleration will be 2 sin 30 divided by 0.2, leaves 5. So the acceleration is 5 meters per second square. Now you can use this and other information to find out the speed of the particle at B. We will use the v square minus u square is equals to 2ax formula. So the final speed, we don't know, squared minus the initial speed is 0, so we won't write that. 2 multiplied by 5, which is the acceleration, and x, the distance, which is 1. That means v squared is equals to 10, making the velocity of the particle at B equals to under root 10. Now moving on to the second part of the question, which is the movement of the particle from B to C. So for this part again, the distance is again 1 meter as shown in the diagram. The initial speed, which will now be the speed of the particle at B, which we found out, is under root 10. The final speed is unknown, as well as the acceleration. First, let's find the acceleration using the forces formula. So the forward force will again be 2 sin 30, and then we will have the friction, which is always equal to mu multiplied by r. So the mu is given us as under root 3 over 2, and the value of r, which is the normal reaction, which is always perpendicular to the plane, is equals to 2 cos 30, since the particle is in equilibrium vertically. This is equals to 0.2 A. Then we we simplify that, we get that the acceleration from B to C is equals to negative 2.5 meters per second squared. Now we can use this information as well as the distance, which was 1, the initial speed, which was under root 10. Now we can find out the final speed, which is the speed at C. So v squared minus u squared, so this will become 10. 2 times negative 2.5 times 1. So that means v squared is equals to minus 5 plus 10, which is equals to 5. That means that the velocity of the particle at C is equals to under root 5, and if we simplify it further, this is 2.24 meters per second, and this becomes the velocity of the particle at C. For part B, they are saying that given instead that the particle comes to rest at C, find the exact value of mu. So mu is the coefficient of friction, and the condition that they've given us is that the particle comes to rest at C. Other than that, everything remains the same, which means that the speed of the particle at B remains the same, which we found out to be equals to under root 10, as well as the distance of BC, which was 1. We also now have new information, which is that the particle comes to rest at C, which means the final velocity will become 0. Again, we don't have the acceleration, and we don't know the value of friction as well. Since we're talking about the journey from B to C, so there will be a component of friction. So we can use this information in order to find the value of the acceleration. So v squared, which is 0, minus under root 10 squared, which is 10, is equal to 2 multiplied by the acceleration times 1, which is the distance. That means that the acceleration is equals to minus 5 from BC. Now we can use the acceleration, the forward force, to find out the value of friction using the forces formula. So the forward force will be a component of the weight. I'm just pulling it rightward, so that was 2 sine 30, and minus friction, which was a resistive force, and the mass, which was 0.2, and acceleration, which we found out as minus 5. So 1 minus friction is equals to minus 1. This makes the value of friction equals to 2. So now we can use the value of R as well as the total value of friction to find out the coefficient of friction, since we know that the value of friction is always equals to mu multiplied by R. So 2, which is friction, equals to mu times 2 cos 30, and we know that cos 30 is equals to under root 3 over 2, and if we multiply that by 2, we are left with under root 3. Mu equals to 2 divided by under root 3. And with that, we're done with part B of question number 7.